Okay.
Just one thing for the introduction.
Yes.
I also want to thank Rocco, who is a brilliant researcher from here PPS in our department, and I'm working with Rocco for I think now 3 years. We are working in the same project, which is the fostering open science in social science research, whose acronym is FOSS, and Rocco is very active in contributing with this topics and methodologies to a specific work package, which is focused on advances in data analysis. And we are working together by hybridizing his methodologies on policy, on agent-based modeling with knowledge graphs and AI. So I think that today Rocco will explain us much better how he uses agent-based modeling for social research.
Yes.
Rocco, now the floor is
Okay.
yours.
Thank you. So can you see my screen?
Yes, we
Yes,
can.
we can.
Okay. So I have just one monitor. So Andrea and Mario, when you say that there is need of coordination, please stop me. And I introduce myself. As Andrea told, I am Rocco Parillo. I work at IRPPS Institute with Mario Palucci, Fabrizio Pecoraro, and others here in the audience, Evelina Sabatel, and others. And my main field is that of agent-based modeling, which is a methodology to study collective phenomena. When I was invited to organize this workshop, I decided, due to the relatively short time and the variety of expertise of all of yours, that I organized the course so that I want to give you an introduction to the methodology in the first section. What I really hope that at the end of this course, you know what agent-based modeling is, what it can be useful for you, and where you can find the resources for your training and your application of the method if you're interested. So the first part will be on general introduction on the foundation of social complexity and agent-based modeling. Then a second part will be a case study on a research project here at IRPPS, and I will show you a specific tool to develop agent-based models. And then the third part will be specifically on the service that I develop within the FOSR project with Andrea and all the work package file. So, whenever you have questions, feel free to interrupt and ask me. You can hear and you can see.
Yes, we can.
All right.
Rocco, can I ask you just one question? Will you share the material with us at the end of the course?
I'm very available. I ask Andrea if there is any logistic channel for this.
Yeah, we'll be publish all the materials if, of course, Rocco agrees, along with the registration of the event and possibly the transcription if I am able to get it from Teams and if it is comprehensible. But for sure, the video recording and the slides can be published, and we are doing so for other courses.
Okay.
Okay,
So you
thank you very
instruct me.
much.
So Andrea, you instruct me at the end how to do after the course, so I can
Yeah,
also
you need
implement.
only to send me the slides, but you already did. So
In
we
the hand
are.
and
If you modify something, just send me the new
yes.
slide that you updated. For the registration, I'm already able to get it from Microsoft Teams.
All right. Okay. So let's go with part one. So we are in the Department of Social Sciences, and I think we all work with society somehow. And I think that despite the diversity of our expertise, we all come to agree with that society is a system made of interacting components, and that as a social scientist, we are interested in unfolding the mechanisms of phenomena that we observe at the collective level. Might be marketplace in economics, might be urban segregation, which is one of my lines of research, or might be welfare state and opinion polarization. But I think that even if we agree on terminologies as a society is a system, as the evolution of social processes, we have different point of view of looking at it. And here is how I want to drive you towards the need of agent-based modeling and what it can be useful for. So when we study concepts as emergence and mechanisms, there is a different perspective that we can have on the different levels of the social phenomena and different methodologies that have been developed. We can have a focus here on the micro to macro level. That's the case of stochastic processes and Markov chains. We can look a bit deeper at the meso to macro level. This is a part of a project or better methodology I'm studying with the people at IRCRES within FOSR, random graph models, where the unit of observation is the network and the evolution of the network, and from the network, the social phenomenon. But there could be cases where we want to study what is the effect, or better, the connection from the micro level of society, let's define citizen, individuals, social actors, to the macro level of the phenomena we observe, such as spatial segregation, economic dynamics, or so on. This is where we go within the field of analytical sociology and agent-based modeling. When we need, has a paradigmatic way of studying the phenomenon, how we can both understand model and replicate the individual cognition, the individual action of people, but at the same time, in the explicative understanding of the phenomenon, moving outside of the individual and understand how the interaction of this individual agent, individual social actor, with other social actors in the society they are part of, lead to the emergence of collective phenomena. If you look at the picture here, I have always spoken about spatial segregation so far, relocation in neighborhood and so on. Imagine if we look at the individual level and the mutual adaptation of people as the key to understand the evolution of the phenomenon, we can see that if we look at this blue house who has some cognition, well, I don't like it here, I want to move to another neighborhood, this household will influence the environment surrounding this other agent, the red one. And this red one agent might change their preferences for this neighborhood, so to move to another place, potentially, affecting again through cascades of events the whole society, unintentionally, of course, but the point is that it's not the individual action of these only households that generate the phenomenon, but how this individual action will interact with that of others. This is all a process of explanation that is both challenging because the social mechanism is not an object of study per se, but is a distributed phenomenon that requires evolution through time, that requires to look, yes, at the individual, but at the same time at the micro level. This can be a challenge. I think someone got in, and I cannot see you in the team, so continue. Let me know if there is anything. And this is something that in the analytical sociology has been developed. It has the Coleman bot. We can define this as the Coleman bot by the author James Coleman as the paradigmatic model of explanation of social phenomena within the micro to macro approach. So what's the assumption and what's the key of reading the social phenomenon? First, that every social phenomenon starts and lives within some macro constraints. Think of it as our society, as the city, the boundaries of the city where we live in. That any action we experience and we participate in is a situational mechanism embedded with the system we live in, that we as human beings at the micro level experience this society and have our individual representation, where we can include our cognition, our preferences, our beliefs, our desires. And when we reply to the environment we live in, when we react to the environment we live in, we generate an individual action. And this is this individual action distributed, as here in the picture, among different people, all interacting in the same context, that these situational mechanisms and this individual action mechanism becomes transformational mechanisms. We go outside of the individual and we transform the social phenomenon through participating in it. So that the macro level is the evolution of the macro level from one state to another one. For instance, society from relatively integrated, here in the picture, to segregated, is a process that passes through the mutual adaptation of individuals and the collective action distributed among citizens. So, oddio, cosa? Okay. Taking back the example of spatial segregation, here is the example I gave you, comes actually from the literature and is a well-known model called the Schelling model. Schelling was an economist, the end of the 60s, when there was a more free movement of relocation of housing in USA in particular, the hand of Russian laws and so far. He, as an economist, wanted to provide a descriptive tool to show how segregation can emerge unintentionally without any racist or any prejudice against the outgroups, but just as an effect of individuals who have some preference for neighborhood composition, even tolerant preferences, and the fact that we adapt within an environment which is limited. The relocation of one individual agent, of one individual household, imagine these squares as households, when they are with this cross means they don't like the composition of the neighborhood and they relocate somewhere else. When they relocate somewhere else, what happens? They bring the transformative process to that neighborhood. So if we are to replicate the individual behavior of one agent, this will influence the neighborhood composition to the other agent, who has now another perspective, another definition of their neighborhood, and that can change idea and want to move somewhere else. The collective behavior, unorganized, not intended, not coordinated by these agents, will lead to spatial segregation. So this is a descriptive model of how segregation can emerge within this paradigm. If concepts are not clear or something, tell me. So how we come to agent-based modeling? Because we do have a challenge here that we live in societies, in phenomena that, as Joshua Epstein describes, are already emerged, and we cannot trace back the phenomenon itself, we cannot trace back the interaction when social interactions are something we live in and we are embedded in. One way to approach the problem is that we can simulate the entire system through how simulating both the individual components of the system, so the citizen, the household, the institutions that constitute the system, and the conditions where the individual action, the individual desires, the individual attributes of agents occur. If we manipulate the conditions and the plan of execution of agents, then we can try to understand the emergence of phenomena as embedded, contextualized, situational mechanisms. And if we can formalize the mechanism, then we can understand how the phenomenon evolved. The phenomenon has the product of mutual adaptation of individuals. So when we come to using agent-based modeling as a methodological tool to address the micro to macro mechanisms. Basically, what we are trying to do, we first formulate, as in any method, a theory of initial, let's call it hypothesis, let's call it theory, initial model of how we think things can work. We have to formalize this into rules and behaviors of agents, and we need then the code. And I hope, I know sometimes people who see agent-based modeling for the first time, they're quite scary because it seems very mathematical, it's very code prone and so on. I want to stress that in my view, coding is something that comes after the theory and after the formalization, as you will do with regression analysis, you will do with other methods. So don't be scared, then if this, don't worry about this. The code is a translation of a formalization of a theory, of a theoretical model that we want to test and that we want to put to the test. So we translate, imagine case of the Schelling model, what we define it as a certain level of preference, call it threshold. We define now a behavioral rule. Tell the agent that he is happy if the concentration of agents similar to itself are above a certain percentage of neighborhoods. So similar wanted, so basically it's the concentration. So the agent is able to compute the concentration of similars in their neighborhood by ethnicity, for instance, and say, okay, I like it here, I don't like it here. If I don't like it here, move unhappy tartars. Tell the tartars, in this case means the agents, who are not happy, find a new spot, move somewhere else. And it's there that we try to track if this individual decision-making process can lead to segregation when coupled with the decision of other agents. So we then test these scenarios that we have built to what-if scenarios. So we set some conditions. We can change the density of the population. We can change the percentage of similar wanted and see what could be the effect. Under what condition segregation could emerge and will not change anymore. Under what condition segregation can be ameliorated. And then we collect the data as another method to understand, to quantify the changes in the system and the changes in the phenomenon we observe. Here in the top, you will see two, say, vademecum or motto. Keys, keep it short, simple, stupid, meaning keep the consistency, keep the mechanisms, keep the ingredients of your theoretical model. So here, at the first step, simple, because it's through the simplicity that you can understand the emergence of unexpected events, or keep it descriptive simple. This is an antagonist point of view, meaning translate a system which is as much similar to the richness of the phenomenon you want to observe. Personally, I am of the KISS side. I would tell it's better methodological. We will have way to look at it. Is there a hand? I see. No? Okay. Can you hear me? I don't. Andrea?
Yes,
Yes,
we
we
can,
can.
hear
Okay.
you.
Yes, yes, we can hear you.
Okay.
We
Go
hear
for it.
Someone in chat, maybe. No,
No,
okay.
if you don't see
Adesso vai,
any...
la team se sei in vabbè. Io non posso vedere, quindi quando qualcosa mi dici tu, Andrea.
Yes, if any hand is raised, I
Okay.
stop you. Or
Is
if
it?
you
Yeah.
don't see any message or any call in your phone that is me calling you because we cannot hear you anymore, then you can go ahead.
What's up?
Yeah.
Is there any questions so far? Is things too complicated for someone? You want some clarification? Ask me in any moment. No. Okay. If not, I continue with part one. Okay. Okay. So this is the the set of all possible usage of agent-based modeling. there is this paper, Different Modeling Purposes, by Bruce Edmonds, that definitely I recommend you. It's a very good conceptual paper that describes you why you will need agent-based model, where you could apply. So, as I said, agent-based modeling is a method to investigate the emergence of collective phenomena, addressing the micro to macro mechanism in situated action within these artificial societies. This can be used for the formalization of a theory. So on the right side, theoretical exposition, description of the phenomenon. On the left side, try to explain the outcome of the society, so the status quo of the society we observe, or potentially to predict future states of the system. I can tell you that this lecture today is on the left part for the reasons of synthetic populations and of the content of the course. So we will not speak about formal models, only theory for development of theory, but rather how to approach geo-based information and empirical data-driven models. So my idea, while I drink something, is that I will develop it, I imagine it, what could be some basic concepts, some questions when developing an agent-based model, so that you can have what I think could be good questions for you when you think of using agent-based model for your research. So the first question that I will ask myself is, who are the agents? So who are the actors that are involved in the phenomenon? And so basically, we need to move from the idea of variables as quantification of the phenomenon to the actors who participate in the phenomenon, which I know it can be quite difficult to imagine. There is a beautiful paper, From Factors to Actors, that describes the philosophy of this perspective. But this is necessary. Think of, I want to study segregation, I want to study fisheries, I want to study economic trades. Who are the people that I think should be involved? It can be people, but it can also be institutions, the school, the bank, who else? And as in any multi-agent system approach, these agents should be provided with some intentionality, meaning they act based on goals and plans, because this is the individual behavioral rules of action that we need to implement. They should be proactive, and they are built to be proactive in agent-based model, meaning they have a plan and they want to reach that plan. But at the same time, they need to be, and they are reactive. So we are not building agents who just do something we tell them to do. We give them some intentions, we give them some long-term plans, and they are able to adapt to the situation. And then there's prosociality terms, which means they are agents able to perceive the others, so they are social agents. In a system like Netlog that I will show you as a tool, all these things already exist. They already exist in the language, programming language, so don't worry. Just it's your paradigmatic way of thinking. And these agents, so I thought while describing you these things, I give you some jargon, which could be useful when you read papers or you try to approach tools and methodologies, which are, for instance, the concept of a state variable. What are those characteristics of agents that do not change? For instance, ethnicity, gender, dynamic variables that can change, and then, and this is very important where you are into the modeling perspective, what are those variables that are shared by all agents? So global variables might be I define the humanity in others, I recognize the ethnicity in another agent. And what are the local variables? So those are variables specifically belonging to one specific group. In the second section, where I'll show you a specific research project we are doing, I will show you this more in detail, so things will become more relevant, in particular why I think it's important to understand this distinction. And there is this, there is a paradigm called beliefs, desires, intention, the one I work with Andrea, and I will add this A, attributes. So just characteristics, which are these characteristics, social-demographic characteristics, for instance, that we need to add. And then we have the concept of parameters. Parameters reply to the question, what are the conditions that affect the phenomenon? Might be the distribution of some characteristics, social demographic characteristics. Might be the, I don't know, the spread of an opinion within this environment. Also here, global, shared by all agents, local, specific to one group. I don't know, you want to model some norms specific to one age cohort and so on. And now we come to the concept more relevant in philosophy of the method, in my view. The concept of evolution, how the phenomenon emerges through the interaction of agents. I want to stress that I'm not speaking about time as a continuous variable, but times as the changes in the system. The changes in the system that occurs because of the mutual action of one agent on the other one. In any programming language, in any way of coding, you will find at some point that you need to add a schedule. So how do agents activate? Agents execute plans. Agents have goals that they want to achieve. They adapt. They reply to the environment. You need to provide a way of enacting within a schedule. At the same time, what are the transition phase that are the outcomes that we want to investigate? So how the system changes because agents interact with each other and influence each other. And this goes to this concept that I think is very important. How does the order of agents' action influence each other? Here there are some concepts where the boundaries are blurred in my view. Can be very technical jargon, in particular when you speak with, I don't know, computer scientists versus social scientists. There could be the same term applied to different topics, and it can be a source of confusion or at least misunderstanding. I mean, I think this is important to understand the concept of synchronization and parallelization. Parallelization, broad terms, is how the behavior is executed. Means you have one agent who starts their plan and the other agent plan starts their action simultaneously. But this is more related on the execution physical of the on your laptop, your computer. What is important is if agents act independently, one agent run their action and then another one run their action. And what is very important to me is the synchronization. Here, the second step means when the behavior is executed. An agent who acts knows what are the consequences of the action of the previous agent who has executed its role. It's important because it means that agents behave based on the shared knowledge of the system, on the shared knowledge of the consequences of actions of others. And that's how they can influence each other and activate those cascade events that you saw with the spatial segregation model. Here I bring you some one paper, for instance, from one work in FOSDRA with Fabio Long and Miguel Ceriani. Is from it's from the work that Andrea was mentioning. We have this system where agents share knowledge of their decision in selection of universities. Imagine the agent 1 here, agent 1, agent 2 are two agents. They are employed at the university and they have received an offer from University 3 and University 4. What happens? That we imposed a plan of execution, a decision-making process, so that they look for one university where someone can introduce them to one top scholar in their elective field. For instance, agent 2 is interested in connecting with agent 1b, and if agent 2 comes to be in the same university with agent one, well, they can think, okay, so microfono? Okay. Agent one can think, well, if I share the same university with agent one, agent one can introduce me to agent 1B, which is my goal. So if I know where agent one goes to university, I can select the same university, hoping that we connect and that we share a common connection. So in this case, agent
Sorry,
one.
Paolo, can I interrupt you?
Yes, sure.
Thank you. Did you also test this paper with a real sample of, for example, Italian universities, European university? I don't know.
Kind of better.
Okay.
We do have the semantic knowledge that Andrea was speaking about means a knowledge graph, so a knowledge of information. This information we mapped is the co-authorship in Scopus literature database. So we have the actual name of scholars in Italy, and we know who published it with whom, and we also know what university they are affiliated with.
Okay.
So what? Yes, in this system, the system is able to interrogate this knowledge graph and provide an inference based on the knowledge of the on the knowledge provided by the knowledge graph. So it is initialized with the real actor, but then what we did, we tried those conditions where we knew that based on the action plan that we imposed, would have provided some outcomes and not others. Meaning, we knew that one university hosts a top author in one discipline, selecting which top author we wanted, and then the agents make a decision knowing that this top author is in that university. So knowing which actors, so which authors are in which university, yes, it is initialized with an actual empirical data set, so the Scopus database. But that there has been an actual mobility is not true. It's just our artifact to understand
Yes.
the mechanism.
It is an hypothesis. Thank you.
Yes, it's an hypothesis. We could have done what you're suggesting if we looked through time, and was one ambition, but we don't think at this point we managed to do it in this way. So potentially it could be possible, but we need to trace then the mobility of each individual actor and select through time, and we have the knowledge graph is for 1 year only because it's very complicated to build this graph. So for all years, it's at the moment
Yes,
was not
because
possible.
in my opinion, you have to download all the curriculum vitae of professor and check it 1 year, 1 year after, and so on.
I'm not the person who did this individually, but you need to have the authorization from Scopus, and then there is this ambiguation of people. It's a lot of work that other people are doing. Actually, I worked on the work done by someone else, so I was liking this. I don't know, Andrea, if you want to intervene because this is something also you participated, feel free to intervene.
No, I mean, you can go ahead. We can just clarify better if you present additional things on knowledge graph. But yeah, just to have a few details more. So the idea of bridging, agent-based modeling that Rocco relies on with specifically the BDI framework with knowledge graphs. Enable, let's say, the possibility to link external knowledge or more structured knowledge that also follows symbolic representation with an instrument that can then leverage that knowledge in order to perform inferences or the kind of reasoning it is meant for.
Yes.
Okay,
But validation is another step. Yes. Okay. So, all right. So, what the point of this paper was how we can predict the evolution of the system when we know how the behavior of one agent depends on the action of another agent. And then we come to the point, given the outcome I have of the system, of my model, how can I read the evolution of the phenomenon? And here is where system dynamics come to play as a way of reading the evolution of the system. These are basic concepts that I think you will need. One is at the tipping point here on the left, meaning a sudden transition of the entire system so that the possible outcomes of the interaction between agents do not unfold to infinite possibilities, but they narrow to one only outcome. Things in terms of segregation, when the neighborhood is inevitably on the track, on the way to become always more and more segregated because it attracts more similars. And then we have bifurcation, meaning the last moment when the system can shift towards two opposite sides. For instance, in political polarization, what is the moment that either the whole population will move to the right wing or the left wing. You were asking about the possible scenarios. And on the right, the definition of equilibrium. These are quite difficult topics, I think, in terms quite philosophical, but let's think of this as a way of the system to act in a identifiable way. So we can define a stable equilibrium when nothing changes. For instance, you have consensus on political positions, people agree, there is not upside down on the continuum, on the spectrum of political preferences. Cyclic equilibrium, this is metaphysics, maybe thermodynamics, meaning the system has a cyclic way of repeating itself, but evolving in this cyclic way. For instance, grass as ships means, imagine you have grass on a mountain, you have sheep who come, they can feed on the grass. What happens? The grass road will slow down, the sheep population will increase because they have more food. When there are too many sheep compared to the grass, there is no food anymore, so there is a decline in the population of the sheep, and then the grass can grow again, and then again. Or gentrification. You can have neighborhoods that initially are deprived neighborhoods. For some reason, they become attractive to other social class members. So there is an increase in the status of the neighborhood. At some point, because of other people coming, some people get out of the neighborhood. So the cyclic evolution of these neighborhoods. And then you have dynamic equilibrium, meaning you have some oscillations, so inflows and outflows that create a apparent stable equilibrium of the system, but that actually is due to underlayer changes. Think of supply and demand in economics. Potentially seems like there is an equilibrium because some products get out of the market and the other get in. So this is the way of understanding how your model has developed. And these are concepts that I think are important to you. How can I identify, this is the most important question, I think, how can I identify how conditions that I have modeled do affect the phenomenon? So we have the concept of global sensitivity analysis versus the local sensitivity analysis. There is this book that I definitely recommend you, Agent-Based Individual Modeling by Reisbeck and Grimm. So global sensitivity analysis, we define pattern-oriented modeling. I identify general patterns. So I have a first picture of the whole phenomenon. So let's call it the space of the model. I can span over all the percentage desired of similars and the whole space of density of the population. Local sensitivity analysis I identify one specific constellation, so one specific condition, and I see how robust the system, the mechanism, the scenario that I observed it is if I change the other conditions of this scenario. In the second phase, second step, I will show you how we did in a case study. So this is the a general possible cycle of agent-based model. So we first implement a theoretical model. We verify that the code we wrote replies to the theoretical model we were expected. There are no bugs, there is no errors. And then we go to the initialize our model to some conditions that we define relevant for our research question. We test what if scenarios, and we run our sensitivity analysis, our measure of understanding how the conditions influence the phenomenon. We identify hopefully some scenarios that we consider best for our theoretical goal, and we test the robustness of these scenarios, and not necessary, it depends on the goal of the model. We validate against empirical data. If you are developing a formal model, this is not something you would be interested in. If you are in policy application of agent-based model, probably also here, it depends on what is the type of data you have available and what is the aim of your model. If you are aiming to predict the phenomenon, in this case, maybe the question we had before, then you want to validate the model and test how you should change the assumption of your theory and the mechanism you implemented to better match the data. It always depends on, as they say, all models are wrong, some are useful. I will say they are useful if they are good in what you are looking for. So you have to clarify what is your research goal and then develop the model to that goal. So we are to the end of this first session. I wanted to do this. So this is again the Coleman's both. So as I told you, the explicative paradigm from the macro to the micro to the macro. And I hope that I think it will be a good exercise for you that you bear in mind within this theoretical framework the questions that you should have in mind, in my view. What are the conditions that affect the phenomenon, the macro constraints? Who are the agents who participate in the situational mechanism? When I identify these agents, these actors, what are the attributes, the beliefs, the intentions I want to apply to them? How do I envisage the evolution of the system? Also better through the individual action of agents, through the situational mechanisms. So how do the agents influence each other? How then I identify the dynamics of the phenomenon? What's my way of reading this phenomenon? Through evolution, through time, and through quantification of the macro outcome I'm observing. Here in the bottom right, I wrote you the reference for the ODD protocol, which is a protocol for building agent-based model, which is quite, say, not appreciated in a paper, meaning as a way to describe a model is something that kills the flow of the model. It's true because it's very disentangling the components of the system, the component of your agent-based model, but I think it's very useful while you are starting think about an agent-based model to clarify yourself these questions that are questions that you will have eventually while developing your model. So my idea was that
Rocco, may I interrupt you for a second? I would like to ask you something. Is there any limit, upper bound or lower bound on the sample size? You said that we can also analyze, for example, institutional behavior, so not individual. So you said, for example, banks.
Yeah.
Or, for example, countries. I was thinking of countries. Is it there is a limit on the validity of the analysis when the sample size is very thin, 20, 30, 40 agents?
If you include a lot of agents, like thousands of agents, you have computational power, meaning you need a machine able to execute the behavior of these agents. So this is something that usually is not done. If we are speaking about above thousands of agents, my doubt is, listening to your question, is your question how many typology of actors I can include, something like that. I mean, you can include banks, you can include schools, whatever you want. The risk is, in my view, that the model becomes too complex to understand because you have the mood
No,
adaptation.
I mean, for example, you started by showing us a picture with a very large number of agents. No, now what I'm asking, it's exactly the opposite, a very simplified model where you do not have thousands of agents, but you have 20, 30, for example, banks operating in a region or in a country, or even countries. I was thinking, for example, international relationships. If you want to analyze this kind of the behavior of one country with the subject to behavior of the endogenous behavior of the other country. So if your sample size is small, it's not very large. Is there any efficiency in the lower bound? This is what I'm asking.
I would say there is, if the scenario that you build through the small sample that you're building is representative of the system you're interested in, and more important is the condition that you want to compare. Like you get the international relation between two countries and you build your model so that this country has to replicate the characteristics of the country at the empirical level, at the macro level, the real size, the country of that you were thinking of. But you need to work to assure, in my view, that your stylized scenario, your abstract model, is representative of the characteristics that are relevant to the phenomenon that you want to study. It's not
So
about
you have
sample
to
size
combine
or
the
effect size.
sample size with the factors that characterize each agent and the relationship between agents.
Yes.
If I may intervene, Rocco, just as you said before, there are some important parts that you have to consider, have to start from. Rosaria Conte likes to say the research question is the important part when you start building the model. So you can do models with a small number of agents, but they will have a very small statistical power. So you do it if you're not looking for statistical significance. And there are very many scenarios in which a research question exists for an agent-based system that doesn't need that kind of statistical significance. If you have just a few agents, a very small number of agents, then everybody is moving at random. What you can get is one of the agent-based application is also teaching and understanding what is the space of possibilities you're moving into. So if you have a few agents, unless the system is so simple that everything happens always the same, you will get a lot of different results. And it's unlikely that you get the statistical power to say this is what is going to happen, but you can use the system to give decision makers a feel of what is the space of possibilities, what is going to happen. So that's why agent-based systems are also used to teach. I don't know if this kind of helped in the reasoning. But there is a wide range of purpose that you do with this kind of things. And prediction is very rarely what you really build an agent systems for. It's more exploration of the possibilities, because for prediction, you need to really be perfectly convinced that you got everything that is significant. I don't know, Rocco, what do you think?
Yeah, I would say this last point is what you do usually, like with digital twins or infrastructures where you have a system which replicates the statistical properties of the target population. And this is the research goal. So, but yeah, also in that case, the important is that even if you have a scaled down size of the sample of the reference population, that the characteristic of this population replicates what are the characteristic of the real size population, let's say in this way. And this is what you do with digital twins. I think it's the term sample. It's not the numerical representation as much as the inner composition and the representativeness of the sample that matters.
Okay, thanks. I don't want to steal much of your time. Thanks.
No. Then I hope it replies and it can go in the right direction. So I will have the second part now. What should we do? Do we have questions or should we start? Yeah, okay. I assume we can start. Okay. So in the second part, I was thinking we will focus on one tool which is available for agent modeling, which is the NetLogo software. And then we will go to a case study so that I hope I can give you some consistency on the concept we have been discussing about. So NetLogo, why I selected NetLogo? Because it's a very user-friendly software. It's an open software. It's very advanced. It is at 7th edition. It is a platform with an interface. It doesn't require very much coding experience. And it is widely known for the social simulation community. And it is supported by a very great documentation. It is able to integrate also shapefile, other source information, reading external sources. I give you an overview of how it works when you will download if you want. It has an interface. It has a code tab where you include your coding and your modeling. The agents we are talking about are called the turtles. They have a list of own variables that you can modify. I will show you how. And the space is a grid space. So it's a lattice, but by the way, it's a space the agents can interact with. The concept that I spoke before, but the synchronization, this is important. NetLogo is an example of simulated synchrony, meaning that agents execute the commands asynchronously. So an agent acts independently of the others, but every agent knows what are the consequences of behavior of one agent who preceded. It is important when you go into the programming that you have these concepts, the ask and the report. So ask means is a primitive that set up a command for the agent to execute, so a plan to execute. Report is a reporter, so says something out of the inputs it is given. We will not go into imagining to program a software model in NetLog because I think it risks to be more confusing in the short time we have. But I think it's important that you have these basic concepts. If I write in this way, ask something, set plan to execute. So ask starters do A, and there's a command block. Then ask starters, another command block, and so on. This is read in this way. The list of agents, so the list of agents in the word, one agent is picked randomly and they execute A. And then another agent execute A. When all agents have done A, then they will do B. When all agents have done B, they will do C. If you write to do something, second step, to ask something, ask starters do A, do B, then an agent does A, and when this agent has done A, it does B. And then another agent does A and B. This is important because this is how you influence each other. So these are things that they need to be taken into consideration. And if on the right side you look at the code type of NetLogo, you will see how it works. I wanted to just give you some blueprints that maybe you're more familiarized when you do it by yourself. You have a family of extensions that are already embedded in NetLogo you can activate, like the GIS for reading shapefiles, so geographic information systems. You can define a class of agents. So as I told you before, who are the agents I work with? You can define the variables shared by all agents, and you can define variables specific to one class of agents. And then you have command block, which are the plans that are executed by agents. So let's implement in a case study. So I hope things will become more hands-on, giving some consistency to you. So this is the work we are doing with, it's a work in progress. We are doing with Fabrizio Pecoraro and Filippo Accordino on childbirth mobilities. So the selection, the mobilities for hospitals where women give birth in the region of Tuscany. It's a geospatial simulation. So it's a simulation based on the geographic information system. What happens and what is the driver of the first research question is that literature provides some determinants of hospital selection for maternity, particular the quality of the hospital, the distance. People tend to go to closer hospitals to give birth in general for health. But there is not knowledge of how the actual decisional process of people work, and if there is an influence of social processes like social influence. There is the word of mouth. We know that people ask advice. They ask advice to their inner cycle. They ask advice generally, but there is not studying or specific data on how these processes actually work together and are combined together. So we said, okay, with agent-based model, we can try and model these actual social processes and individual processes all together and see if we are able to replicate the data on mobilities. And we were lucky enough because in Tuscany, we have at aggregated level knowledge about mobilities, meaning we know for each hospital where women gave birth originated from in the region. So we are speaking about intra-regional movements. We have information on the PME, which is the performance indicator of hospitals. So what indicate hospitals according to their performance, regional level performance are considered good hospital or not. We have the distances between the hospital and the municipality where women have residency, so to track the actual mobility and the distance. And we came up all of this information to geographic information system, so shapefiles. As you see in the picture, we use NetLogo to map these agents to the space. So these are, every dot is a woman who gave birth. The triangle here, for instance, I will show you in the next slide, are the hospitals. And we have the boundaries of municipality, so the micro level municipality. Okay, so overall, what we wanted to do is to implement a model where we have the spatial distribution of women in the region. We have women that when they are signaled to be pregnant, they need to select one hospital, and we model the decisional process of these women. And there are two ways of communication that are recognized in the literature, meaning seeking specific advice or routine communication, say hearsay in everyday communication. Why communication? Because communication is considered the way through which the opinion of hospital is built. Might this be a real opinion, or might be just a common sense opinion, or an opinion not supported by the actual ranking of hospitals. But what happens that if one woman selects one hospital, then their opinion is something that can be updated out of experience, the experience of the real performance of that hospital. And so women who have selected, for whatever reason, one hospital can become those that vehiculate the real opinion, the real ranking, the real quality of that hospital to other people, meaning that higher ranking hospitals might have more chances to be selected in the next step based on the possibility that this woman has communicated their experience to others. So I will go in details in the mechanism, but what I thought that could have been useful for you here to replicate the questions that I previously presented to you applied to this model, so that you have an application of the questions, application of the concepts to an actual agent-based model built in NetLogo. So let's get back to the questions I had originally. So agents, who are the actors involved in the phenomenon? These are women. As I told, initially they have a random opinion of hospitals. So let's say it's a gossip, is an opinion that is not coherent with the actual performance of the hospitals. They have to select one hospital and they seek for advice. It's advice for people in their cycle, or they are based on what they heard about the hospital in their everyday communication. When they select an hospital, they have experience of that hospital, they can update, or better, they do update their opinion to the actual performance of the hospital, and they can vehiculate what is the quality of that hospital to the population. Hospital on the other side are distributed in the space. They have a ranking, which is the official empirical regional ranking that we got from the data. And they just started. They actually do not act. They are a physical unit. And then we have the parameters. What are the conditions affecting the phenomenon? Here, as I said before, the model that we are going to describe are models that replicate empirical scenarios. So we have the boundaries, the space, the unit of space of the region, the municipalities of the region translated in the GIS file. The GIS file, NetLogo, is very useful. Here I write you how we did. Might be useful for you. There is plenty of, there is a library, the documentation how to incorporate GIS file. So we incorporate the boundaries, the map. So we got the distances, normalized distances between municipalities. And so distance between one hospital and the municipality of women. We created the class of women and hospitals, and we set up the time. This is how you set up the schedule, because I told you you need a schedule of time that the mark how the agents execute the plan and in what order. This is how you do in NetLogo. In other programming language, you will have other ways. The way that NetLogo is a very useful tutorial and hands-on approach. Today, you can also use ChatGPT if you need some recommendations. So you will get accustomed on how to do this. Then we go to the question so that I can describe a bit more text-wise. I think it's important how the model works. How does the order of agents' action influence each other? We went into the literature and we got these basic concepts we built on. On one side, discrete choice models, which are a class of models for selection procedure. If you are in regression model like conditional logit, mixed logit, they come from here. So it's a way to model the selection decisional process. And each agent for each hospital define a utility. So how much I like this hospital, what's the utility that I attribute to this hospital based on two characteristics that we decided to be relevant for the literature, and because we had the equivalent in the empirical data. So the distance to the hospital, The closer the hospital is, the better it is. I will describe later how we did this and why. And the opinion of the hospital, which is my personal opinion, which can be an opinion that changes. So it's a dynamic opinion. Can change because I get influenced by other every day when in our daily routine discussions, or because I seek advice specifically to people who had the experience of that hospital. And when I activate these two types of communication, this is important. I am the receiver of the communication, but if there is a receiver of communication, there is a sender of communication. And this is how social influence occurs. As I told you before, women who gave birth have direct experience of the hospital and they can vehiculate this experience to other ones. So they can influence the other clinicians. This is the part of social influence that we include in the model, and this is the component of social processes that listeners say are not actually known how this potentially can work. We know that they are there, but we don't know how they actually work. And this is something we can try to do with Artemis model. That's it. Okay. So far, is there any question? No. I don't see you and I don't hear, so I think I can continue. When I present this, can you hear me? Can you hear me, Andrea?
Yes, we can.
Yes.
Okay,
Yes.
so
Yeah,
sorry.
yeah, we're here.
No, è perché non vi vedo, quindi poi... Ok, allora, when I am present these key elements, so these parameters of the phenomenon, what are the conditions affecting the phenomenon? What I did for each of these key ingredients, I put here on the left what it is, why we implemented the height words, and then in the green box, what are the parameters? So the conditions, the parameters, numerical parameters through which we quantify and we model, we quantify this component of the phenomenon and why it's useful. In the blue box, the formalization of the theoretical aspect. So what you have on the left side. So how this theory is translated into a mathematical formula. So it's a formalization, and how then the formalization has been translated into the coding. And this is the work you will have to do when you build an agent-based model. So we look at this choice model. As I said, we have to define a drive to why the agent selects one hospital. So this is definition of utility. Utility is another term, can be quite difficult to grasp if people are not in the literature. Means we attribute a importance, a relative importance to this hospital compared to other hospitals. And why one hospital has a higher utility compared to others? Because they have some characteristics that we might consider more important or less important. This is this parameter beta that you see here in the definition of utility, which for us is how important is the distance to the hospital, or better, to shorten the distance to the hospital. That's why it's negative, or the opinion that I have about that hospital. When we define utility for each hospital, then we can select the probabilistic way. So we compute the probability of selecting this hospital compared to the others. Why these parameter beta are important? Because they are the weight that define the utility. The higher that parameter is important, the more the hospital that maximizes that part of utility. So it's shorter if the distance is very important for me, or it has a high ranking if for me it's very important that I select an hospital that has a good reputation. The more that hospital is likely to be selected compared to others. If these beta are 0, so meaning I don't care about any characteristics, I will select randomly. That's why there is this is a random component. I select randomly. So what we did, we translated these two betas that are in the theory, that are formalized in the mathematics, into quantities of the model that we can manipulate, the parameters. You can read here, weight, distance, hospital. and weight opinion. Why this is useful? Because we can shift towards the whole space of weights that an agent can have for how important is for them these characteristics of this other one. And then we computed how the hospital, which is given the attribute for these characteristics, this utility, will be selected. Next step is the social multiplier. As I said, we want to experiment on the two types of communication. A direct seeking advice, meaning people ask in their cycles who are what people think of the neighborhood, of a specific hospital, because the literature says that this is a strategy that people usually use, or people just are based on their common sense, what they hear every day in their neighborhood, in their city.
Rocco, may I interrupt you a second? Sorry if.
Yeah.
One question. Utility that you showed us depends on hospital characteristics and the distance. Is it true?
Hospital characteristics is the opinion that the agents have of their hospital. So it's an opinion that can be real.
No,
based
my
on opinion, or
question
not
is
real.
the following. Is the following. Since you have this very rich framework, of course, let's assume that you have a concentration of agents around a very good hospital, Gemelli, for example, or Cardarelli in Italy. Then what you choose, the optimal for you, could be the optimal for another. And if there is a crowd on that hospital, then it becomes not anymore optimal. What I'm saying, is it possible to introduce, I know that I'm making things more complex, but because this is the richness of this methodology. The choice of agent endogenous, in other words, what you do depends on what other people does. So if there is a crowd or a queue, a very long queue on an hospital,
like
then it is not anymore optimal for you to do this. So in this utility does not depend on what other people does. It's just an exogenous utility and
Antonio Rossi, può chiudere
okay, so this is what my question is. Is it possible to take into account what other people are doing?
Yes, you can. And it was just we cut it out from our theoretical view. In a previous version of this model, we wanted to include the capacity of an hospital, like if the hospital is full, you have to wait, maybe you need to go somewhere else, or as you say, the utility will decrease because someone else has selected the hospital. It's a very good question, but we needed to start
in Italy, for
so
example, people I know they go from Naples to Milan simply because it is quicker, or of course they take into account also the quality of the hospital doctors, but also the possibility to access more swiftly, more quickly to the sanitation, to the. So I think it really strongly depends on what people do.
Yeah, I agree,
Rocco,
but it's also true that Fabrizio knows
Rocco,
the topic.
come in? Yeah. It actually is a very interesting perspective, but we did another work on the access to external facility. I mean, external from the regions you live for surgery, like hip transplant, and that was in that model the queue or the waiting list were included in the model, because of course if you have to wait 6 months it's different than if you have to wait 3 months. And that's why, as Salvatore said, sometimes not only for the quality you are pushed outside your region of residency, you go outside. But I mean, of course, the quality is also the time you need to wait for a transplant. But in this case, it is quite difficult that a pregnant
pregnancy.
women that have to deliver is has to wait. I mean, because the delivery has to be done in the day. So it's not possible to wait, or at least in our opinion, in the model, was not the most important thing to consider when the woman has to choose an hospital to deliver. Also considering that we in the Rocco's model, we the woman did not choose the hospital the day when she has to deliver the child, but months previous, so at the beginning or during the midterm of the pregnancy. So it's quite difficult, but you got the point, Salvatore. But I don't know, Rocco, maybe we'll introduce this or already spoke about it. But when you have to develop the model, sometimes you have to take into account some variables and some not, depending on the importance of these variables. Otherwise, we will have a full compliant, and it's not possible to have a full a model with full variables.
The model can do this, of course, with the endogeneity image embedding. In our case, it's unlikely that you have to wait for the specific case of pregnancy. This is a bit, but you can do it absolutely.
Mine was not a critic. I was just questioning if it is possible to extend the model. Since it is a very rich tool, this is what I was asking. Thanks a lot.
You can. Actually, the opinion, I think I already corrected you on this one. You said the quality of the hospital is the quality perceived by the agent, and that quality can change because it will change through social processes, and we focus on this. The point is that also we were more theory driven. So we say, okay, pregnancy is unlikely that, as Fabrizio said, you have to wait because people will make you wait for pregnancy. It's something that happens out of the blue. It's also very likely, and this happens in the data, it's unlikely that you go to a far hospital to give pregnancy, to give birth. It's likely that you will select an hospital very close to you.
Rocco, but also the quality depends on what the people do. Just yesterday, the guy who was left on the floor, I do not remember which hospital, he died at the end. I do not remember which. So if there is a huge access to a hospital, then the quality as well can go down. But anyway, this is what just...
We will need some more data-driven information in that case, I will say. But it's something we can include, and it's a very good suggestion. Thank you. So, we can, oh, sorry. Oh, here. Okay, so the social multiplier is in the act of asking specific advice how we can model how much I will be influenced by others. So in this case, we implemented this through a weighted average. Why? Because we thought, okay, we have a list of friends I ask advice to, but I can give, and this is the hypothetical scenarios that I compare to others, I can give a different weight to people who actually gave birth to that hospital, so they have an actual experience. By actual experience, we mean the PME indicators, or people who speak themselves out of common knowledge and they don't actually have experience of that hospital. So this is the weighted average, this point, with this weight, which is 1 if only women who have gave birth are listened to, is 0 for other agents, meaning if you don't have a direct experience of this hospital, I mean, I listen to you, but I don't get influenced. And this theta parameters instead is the weight of actual social influence. Why? Imagine this component, so the collective opinion of friends, the collective opinion of others, minus my own opinion, What is this? The distance between myself, my opinion, and the opinion of others. If this theta is 1, the whole opinion that is made by my individual opinion plus opinion of others aligns completely to the opinion of others. If this theta is 0, all of this component is deleted, meaning my selection is based exclusively on what I think is the right opinion about that hospital. So we included these ingredients, these conditions in the model, and we translated into these parameters. So the weight of the social multiplier, the social influence when I ask specific advice, the weight given to the experience of having given birth or not, so based on the literature, the distance threshold, means how far my friends live, so how homogeneous or heterogeneous based on the sharing the same municipality these people are or not, and the number of people I seek advice to. To keep things simple, we left that agents have friends in their municipality, and if they don't have municipality, as close as possible. So, and we kept just 50 people to ask to, just to keep things simple. Last ingredient that we included is the opinion dynamic, which is in this case to represent the day-to-day communication. How this works: when a woman has given birth, as I said, they can vehiculate the actual opinion, the PNRE ranking of the hospital, and they communicate to other people. Other people, according to this opinion dynamic model, which is a thing in the literature, it's called the Fuan model. Sorry, I didn't write it down. It's called the Fuan-Weisbach model. The assumption of this modeling of communication, how it works, that people listen to others if the opinion of others is not that far from my own. This is called the latitude of acceptance. So basically, a given one agent that we call O, I, so the opinion of I is minus the opinion of the other agent, the one who communicates, is below some latitude of acceptance, latitude of uncertainty. So is a threshold below which I am available to listen to others. I let myself be influenced. How far I can be influenced depends on this other parameter mu, meaning if mu is 0, I will not be influenced. If mu is 1, of course ranging from 0 to 1, I will completely align with what other people tell me. So, and this is what happens here in this blue box. So if the opinion of the other agent, in this case the woman who gave birth, is below my acceptance to listen to others, I will be influenced with some degree. Meaning, if we set epsilon to 0, so the latitude of acceptance to 0, I don't listen to anyone. So communication just doesn't happen. I just remain with my opinion. If epsilon is 1, so I let everyone speak to me, I listen to everyone, potentially I can be influenced by everyone. And we set mu 0.5, meaning I align to the others, but I just don't embrace completely their opinion. Just for clarification, since our opinion go from -1 to +1, the epsilon has to be between 0 and 2, but just a scaling. So consider maximum, we took the conditions where agents do not listen at all, 0, and the case where agents listen freely everyone what they tell them, so it's 2. Okay, and now this is something, this is important, useful, more than important, useful for you if one day you want to use NetLogo to explore your model. Behavior space. This is a tool available from NetLogo. This is a tool to set up experiments, sequential order, so run mass experiments. this is a tool. What it does, basically, it lets you set all the possible conditions of the parameters of the model you have, and collect measures, collect outcomes of your system. So it just lets you run the experiments, basically. It's important. I give you as a piece of advice. I did this with the students of the master when we had more time. So I just give you here more hints. Use a server, because it's true that you can write it on your laptop, but the computational power when you have very many conditions, it's high. So you need a server. It's just a piece of advice. You don't waste your days and your time. And here on the right, I write you how to set up the experiment, which I think is useful. If I write EPS birth through, meaning the latitude of acceptance, the epsilon, those who give birth in this way, 0 and 2, means I take the conditions where EPS is 0 and EPS is 2, interact with all other conditions. If I write in the brackets 0, 0.12, means get all the conditions where the value of EPS is 0 to 1 instead of 0, 1. So it means it takes 0, 0, 1, 0, 2, 1.9. Of course, then it's a matter of rule of time, of your available time, available computational power. We had limited computational power, in this case, and limited time. How many conditions you can explore, and how relevant this can be. So it's up to you. I just give you the tool and for you to investigate. Same piece of advice: when you start, it's best to look at the extreme conditions, but this is our way of approaching that come by experience and your availability. So the questions that we had with sensitivity analysis, this is a kind of adapted sensitivity analysis, because we had this more time and more computational power, so we had to make very drastic decisions. We couldn't explore as deeply as we were hoping for, but we tried our best. And we hope that we can already show something. So we compared the what-if scenarios. In this picture, I can show you what we did. This is the case where we isolated the effect of the social multiplier, meaning in these conditions, agents only communicate in their everyday life. They do not seek for advice. And we manipulated the effect of the distance to the hospitals and the opinion of the hospital. So this means that we took these extremes of very low weight for the distance, -1, and opinion -1 that I do not report here because I was not interested in the results, and -5 and 5. What we can see in the up box, effect size condition A, here we isolated even the effect of opinion, meaning agents do not consider the ranking of the hospitals. They only choose based on the distance. So what we can see, the blue one is the distribution aggregated by ranking, clusters of ranking, which you can see on the bottom. If agents, so the blue one is the empirical. If agents only based minimally on the distance, -1, what happens that today we select hospitals that are farther in space compared to their municipality. They choose farther than what empirically happens, and that the difference between rankings do not emerge. If they increase the distance, the weight of distance, so it's the green one, -5, meaning they want hospitals closer to their municipality. Yes, it's correct. They directly select closer on average on space, but it's true also that they approximate more the empirical data, and slightly, but not consistently, there is still a not very sorting by ranking. So you see the green ones, they are closer, even a bit more than empirical happens, especially, and the ranking of hospital does not emerge. When we included also the opinion, the weight of opinion, high opinion 5, so I want to go to one hospital that I consider a good hospital, and remember that in these conditions, they are influenced in everyday life by those who gave birth. What happens that we approximate even more space-wise, relatively, but in particular, we approximate more from ranking also, and we come closer to the empirical data. So one way of interpreting this for us was this can mean that if I made my decision, or better, made decision of agents only based on the distance, seems that higher weight for distance replicate best data, so that agents select based on decision on going to the closer hospital, real people selected based on the closer hospital. And if they select based on the closer hospital, they are more likely probably to replicate, to communicate the real ranking of hospitals, so that then when agents decide based on the opinion also, hospitals who have a higher ranking are more likely to be selected. So let's say that our conclusion here was agents between distance and opinion. Distance is more important. This opinion reinforces the effect of distance because through distance, agents can vehiculate one coherent sort of rankings, so that hospitals who are more relevant, better according to performance indicator, have more chance to be selected. And then we said, okay, what happens if then I isolate the communication day a day, so the common routine communication, and I instead consider the case where people only seek for advice. In this case, then I compare the condition where they seek for advice and they only get influenced by those who gave actual birth to the hospital, to the condition where they seek for advice, but then they just get any advice that comes. They assess equally the quality of feedback, the social influence of feedback from those who gave birth and those who do not give birth. So W1 on the left is when agents are influenced by those who gave birth. On the right side, the W0.5, the effect of experience doesn't matter. What we can see is that when agents are influenced by the experience of the others only, they tend to overestimate the actual selection of hospitals compared to the case where they do not give this privilege to those who gave birth. So you see here on the left, the counts of hospitalization for high rankings is much higher than empirically and compared to the other clusters. And that this effect is higher when the distance has a lower effect in selecting of the hospital. So it still seems that choosing an hospital based on the shorter path is something that aligns with the corresponding ranking of the hospital, but we are still not sure about this because this needs to be studied better, and this in particular requires to understand the distribution of hospitals in space, which is one thing with this data-driven model, because in Tuscany, what we recognize it almost immediately, there are lots of good hospitals that are in areas highly populated. So it is likely that this means the hospital closer to my place on average is also a higher ranking hospital. So we will need probably to look, and this is what we are trying to do now in the next step, to look at the macro level, even within the region of specific areas like Maremma or so on. And so the conclusions broadly were that when we then included both common communication and direct advice, this effect seems to ameliorate, or better, it's always the common sense that common communication that decreases the polarizing effect of direct advice. This can happen, this is my hypothesis so far, it happens because if I seek direct advice for people who gave birth and they selected good hospitals, then it's very likely that everyone will provide me suggestion on a high ranking hospital. So I will myself try to go to the high ranking hospital, and most opinion will shift towards the top hospitals that get selected. But if I get somehow, not confusing, but say average on the opinion, because I'm exposed to several opinions. Someone tells me, okay, this hospital is top. Someone tells me, okay, this hospital is not 1 on a scale -1 to 1, but it's 0.8. This one, okay, it's 0.5. Then in that case can be that even if I consider relevant the opinion, I'm exposed to more options, and more hospital can come to have similar ranking of opinion, and this means that there is not a polarization towards top ranking hospitals. Of course, this means that we need to address more the relation between space and the two types of communication, but it's very important for us in this step that we look also on the dimension of the space and the sub-regions differences, and so heterogeneity of the effect of distance. It's important for this condition of Tuscany. But what I wanted to tell you, this is how we can approach a phenomenon through an agent-based model. Hope this is something that was useful for you to have the end-on on the model. And say the connection to the next step is that so far we had plenty of information on the region, of the reality, on the situated system of Tuscany, but we might have conditions where we don't have all of this information, and that we need somehow to extract the relevant underlying structural conditions of the system we want to investigate. And this is what we do with the synthetic populations, and this is what we do in the one of the service, and my specific service in work package 5, which is the next step contribution to this lecture. So I ask first if you have questions. Carlo Proietti. Carlo Proietti, then Luigi, and then Antonio Rossi. Okay. Carlo Proietti.
Hi.
Okay, salve.
Thank you very much, Salve. Shall we take it in English or Italian or back to Italian? I don't know.
Let's
English?
do English, I would say.
Okay. Thank you, by the way, and very interesting talk. I have a question on the opinion dynamics part, especially on the mechanism of averaging opinions, and which I don't know if I grasped every detail, but it seems that okay, you employed the averaging mechanism, the typical averaging mechanism, and implemented the typical mechanism of influence on opinion dynamics that is already adopted by Exelman and Krause in his model, the bounded confidence.
No, it's another one. Okay.
Yeah. But what I mean to say, it's the idea is that I listen to similar ones, and if you are too dissimilar from me in opinion, I don't listen to you.
It's not bidirectional. It's the woman who gave birth goes to their municipality back, and they
Right.
want to share their opinion. So it's the receiver who then accept or not to listen to the woman who gave birth. But the one who did not give birth will not suggest it to the woman who gave birth. So it's not bidirectional. So you don't have a consensus towards the average opinion. It cannot happen here.
Right, right. Okay. No, no, no. I was not meaning I was not for seeing what happens in the end and or saying
Okay.
that's my question was more general, and I was I would like to ask if it seemed a typical this typical averaging mechanism and the filters of others' opinion, like I listen to you if you're similar to me, is widespread, widely used in several opinion dynamics models, but is it used here for a reason or just because it's debatable? I mean, my feeling is that it's debatable as an assumption.
Okay, I would
So
say
I just wanted to know if you adopted it or hardwired in the model because of it's considered as a standard mechanism of
no,
averaging opinions
No.
or opinion updates, or there's another reason for that.
There is another reason. First, we wanted to try only with social multiplier because it would have been simpler. But then we recognize it. In that case, it will be narrowed down to the fact that you are asking actively to people. While instead, from the literature of opinion dynamics, we know that these people tend to communicate with those who have similar, and this was a good mechanism to simulate a parallel mechanism of communication in the everyday life. So it was selected as an antagonist to the social multiplier. But it's not to avoid then the convergence to the average, which we know happens in opinion dynamics. Then we selected that this would have been done only by those who have given birth. And it does replicate, not that the woman who is going to select the hospital seeks for advice, but the woman who gave birth decides to spread their opinion of the hospital. So it's another actor who plans with another way of communication. And this way of communication, the best way to model it was with the F1 model. This is the F1 model. This is the so I'll let you answer, but you understand me with this mechanism of the model. So it's the way of communication starts from another agent, and this agent is the one who gave birth against. You're right to correct me on this, right? We will point better when we describe the model. Is the woman who gave birth starts the communication according to the opinion dynamics model because it's a communication from one to many, while instead the woman who seeks advice, they go to many and asks within their individual to model their individual decision process. And that's why that the social multiplier there is the way of communicate, because communicate means for us here being influenced in the opinion. So it was not included because it's good. It was included to simulate day-to-day communication, a parallel communication to the social multiplier. Does this clarify?
Yes, yes, yes. Maybe there are some details that I need to grasp better, but
Okay,
yeah.
we can also
Okay.
discuss. It's also good for us.
Right. No, just my point was just if I have other 30 seconds is that there are this mechanism of opinion update is just one among other possible
yes, of course.
mechanisms. So Michael Mers and Andreas Flake, for example, in their argument-based model of opinion dynamics that you might know, provide a different mechanism.
It's still based on the fun because the alternative was Krause, where you average on the opinion of all. And we tried also to implement the Krause, meaning you get the average of all those we are exposed to and you converge that. and that's not the adic, and it's not depending on the level of acceptance. In that case, we would have a sudden convergence to an average, which was not credible, because I mean, you don't just adapt to what all people tell you for a choice, for a mechanism like hospital opinion. It was also a matter of convergence, and we said, okay, it was more realistic to have a model than DOF one when we have then to simulate the common day communication.
Okay. Well, I don't want to see more time from others. So,
No, but
from other
it's great
questions.
question. Thank you. You can also
Thank
contact
you.
us whenever you want. We appreciate
Thank
it. I drive Andrea. There is Frank, but there is someone else in the queue before. There was, yes, who was?
I'm not Luigi, of course.
Luigi and then
I'm
Franco.
Assunta Martoni. So, just wondering something more about the process that you use to choose the relevant agent and the relationship between them. So, what's the process? Since Professor Capasso said that you can consider also other relationships, so how you can get it's a process of I don't know if
we wanted initially to model also kinship, professional relations, networks, but it was getting too complicated. So we said, okay, let's try one way to observe how the diffusion of opinion can, let's say, interact with your spatial proximity, so your municipality. That's why we said, okay, let's get friends to be in your own space. And we had also another condition originally where the friends were more randomly relocated in the region, which would mean that potentially you are exposing more to more heterogeneous opinion if these opinion of others depend on the fact that they had a different distance to cover to go to the hospital. But it was just too confusing, and we didn't have time to delve into it specifically. Including other networks like family. We also had originally imagined they go to a common consultory, and the consultory is the space where you can create new networks. Just adding too much. Somebody else, no, it's better keep it simple. We understand, and then we add the complexity next steps. So we gave up. It's a good point, but it's better to not add just to add, and it was not the right decision at the time.
Thank you.
Thank you. Franco Alberto Gardillo.
So hello. So thank you for the talk, first of all. So my background is machine learning. I have only a small experience with swarm intelligence. So forgive me if my question is too naive, but you have plenty of thresholds, ranges, human designed rules. Okay, so how do you validate at the end your model? So even if you want to test different parameters, like if you have a range of continuous values and you only choose 3 of them, or different averaging of opinions. So how do you validate the model? How do you tackle the bias in the data or in the design process? And since I think that all these simulations can be very expensive, is machine learning used as a surrogate model to validate in some cases when you have a lot of agents, for example?
Machine learning, to be honest, I cannot reply. I know Fabrizio has done something with machine learning. I haven't worked on it, so I don't have the expertise, to be honest, to replicate on that. If Fabrizio wants to add later. On the terms of validation, I will say we choose as indication so far if we can replicate the empirical data. That's why in the box I share with you and say, okay, let's see if we are able to replicate the distribution of simulated selection of hospital to the empirical experiment. So in that case, the validation will be as how the mechanism identify best matches with empirical data, so it can be considered reliable in explaining the data, which is not about the theoretical understanding of the actual mechanism in all unfolds of the model, but that's more a theoretical question. So we decided, okay, we first tried to match the data, and from matching the data, abstract the mechanism. So validation for us was matching with the data. And this is, or you're right, this is computational costly. Now we adapt it so that we can overcome this relatively. We narrow it down to just some parameters, saying, okay, the one that is relatively low, not zero, because zero would mean totally random. So that's why -1, and one which we consider high, but we haven't tested on the continuum if we could not find something not linear or something like that. We need to do that. So what we will do is keeping in mind to match the empirical data and expand those parameters, the beta for the weight and the opinion. Ideally, that would be, but it's, I think, too ambitious to look at the individual distribution of each hospital, because we have this, both empirical data and the simulation data. But it's too ambitious because you get some mobilities that are very rare and so on. So that's why we aggregate it by average. So we know that if we go within each cluster, probably we will find quite heterogeneous outcomes. Then we have to test it, and I'm pretty sure this is very likely. That's why it's a bit too ambitious to replicate the exact mobilities. So, but if we find the general trend, we will be quite happy because it's already we are explaining something in this case. Fabrizio is still here. You want to replicate about, because I've not done machine learning, so
Rocco, I don't know if you have an additional part to your lecture today, and the time is sorry, we scheduled the lecture till 1 p.m. So if you have an additional part to introduce, I ask you to go straight and also fast.
All right. So okay, it's good to have questions. So if you have questions, ask me. To me, it's also fine if I don't show. It's not okay. So let's do it. I do very quickly. As Andrea said, I'm part of FOSS project. FOSS project wants to develop an open cloud for social sciences with innovative tools. And Andreas and I are part of innovation data analysis. And what the goal of this third section would be is to speak about a bit synthetic populations. Also going back to the question by Salvatore Capasta at the beginning, what matters when we want models able to to reply specific to a context is that my model replicates the intricate, the abstract properties of the target population. This is what you will do with the digital twin societies, and this is what you likely do with the research infrastructures. And one goal of FOSS is to develop research infrastructures. So my task in FOSS, one of the tasks and the main task is to develop a method for synthetic populations extraction. I just pointed to this book by Mario Paolucci and Luciana Taddei on the research infrastructure and logical data. And there is our chapter on synthetic population where you find the theory that I described here. Okay, so I just write. Synthetic populations are a way to extract this information. It's a family of techniques. There are different approaches. Let's go right. So one is synthetic reconstruction. I reconstruct the joint distributions that I don't have from the data. Okay, so you will have this slide. It's fine. If we have to go fast, I go fast. Then we have combinatorial optimization. These are stochastic models like Markov chain, where you throw random numbers and try to replicate the intrinsic axis, the radial intrinsic axis, the distribution that you observe from empirical data to a continuous process. Then you have the machine learning approach. So I will not describe the detail. This approach is a new approach which also I explored, but it has some limits because the machine learning needed to be trained on specific data sets to then develop a mechanism. And you risk that a population underestimated risk to be ignored. This first section, you have the chapter, you will have the slides. So just to show you the pros and cons and provide you some advice where to find a way to estimate the synthetic populations from methods available. Then we come to my service. I will go quickly and I will invite you in the end to the first days, which I want to publish as slides and let you know. Synthetic population generator is my service, is a service to elaborate data, so to have the extremes of a synthetic population. It follows as the wolf of the project, the open science paradigm. So I will show you the method, the algorithm that I developed, and the way this is delivered as a software, as a system. So according to these pyramids, which is the three methods of delivery that reply to three different steps of open science philosophy, from having high modifiability available to the researcher, to the user, to high executability, regardless of the resources you have available. So I started implementing an evolution of the iterative proportional fitting. I didn't explain the I didn't have time. So basically, it's a way to compute a weight from the marginals for each unknown joint category, estimate these categories, compare to the marginal that I observe from the data, and correct my weights. What I did is to abstract these multiple iterative proportional fitting so that this can be generalizable, it can be automated, you can filter the results as you want. And I tested the algorithm with OpenSalute Lazio, which is a healthcare data set. Very important because healthcare is one of the most difficult type of data to reach, in particular at the integrated micro level. But OpenSalute Lazio allows you some joint distribution, so some conditional, some joint categories that are useful for validation of the algorithm. So what I did, I worked with the gender, age, hypertension, heart failure in the region of Lazio. I know the distribution hypertension, heart failure over age. So here on the right, you have how the data needs to be input. Here the algorithm, I will describe very quickly. So what the algorithm does, you as user provide an input with your aggregated data. It identifies the total of the population. It identifies the marginals, so the aggregated data. It identifies if it has the categories, joint categories you can provide. It identifies all possible combinations, which are all the macro level characteristics intersected that are available from the dataset. Then what it does these three passages. So recognize the categories. If there is no categories, the joint category is 1. Look here on the right, how I estimate the percentage for each crossed categories. If I know the joint category, then I compute with the computation of the estimate of percentage for that crossed category. But basically it's a condition probability. So for instance, I know the number of people who don't have a failure and are age 30 years old over the number of people who do have 30 years of age. So it's the condition probability on age. And then I can compute what's the probability of people who are 30 years old on the whole population. And then I compute these products of probabilities with the count of males over the population. Meaning, if you come to the first data, I will describe mostly, I don't want to create confusion. If I want the estimate of the percentage of people who are male, 30 years old, with HPT and HF, so hypertension and heart failure, I need to compute all these probabilities, and the code just identifies them in the data that you give them and adapts. Once I have this, means that when I have these probabilities for each crossed category, I can compute for a size of the population that I want to estimate. Might this be the initial distribution, the initial population, so I compute the joint categories within the actual population, or I want to scale up to a bigger or smaller population. So this means that I give an input to the aggregated data, the output will be the all possible categories joined within a population I want, and at that point I can filter potentially, if I want all information on females, all information on Taylor, it's just a way to customize the outcome. So the code is available as an open code, which is important. Open science means people can integrate the code I wrote with their program. It's highly modifiable, but you need coding and you need dependencies to run the model. It is a standalone program, meaning an interface you can download, you can work on it on your computer, and you don't need dependencies, so you don't need Python, which is the native program whatsoever. And it is available within the VRE, which is the virtual research environment, another service of FOSS that enables people to develop their algorithm through an interface and available to everyone. So it's open for free. You will have also the link here. It uses High servers, so HPC, Frontier for Science, which is an initiative of Europe, FOSS is connected to. But of course, it's not modifiable. You just go there, run the service, and get the output. What this service can be useful for, because it can be useful to recognize all those joint categories, abstract, unnecessary, relevant at first eye, underlying characteristics of the society in the whole complexity, which can be used for an agent-based model, but it can be used also for other models like spatial models or regression or what else, in general for policy advice that need to know what is the reality of a society. I know I ran fast, but if I lured you and I teased you, these services will be offered in the future in the FOSS market, but in the real future, for next week, I think basically, from 4 to 6 February, there will be the FOSS days where we will present the service and we present a lot of suites of services from FOSS. So register and hopefully join us here in Rome. Hope I tease you at least for this event. So if I had to close, Andrea, I would not.
No, thanks for speeding up the last part of your intervention. Many thanks for having described your research interest in a very detailed way, starting from the very beginning, let's say, of all the aspects. So I think that we can have a few minutes more for additional questions if any arises from
If
the
you want,
audience.
I'm here. Don't worry.
Yeah, I mean, if it's almost lunchtime for most of us, but I think that just because Rocco is still here, and I think that it's worth to be, I mean, its presence is worth to be used for clarifying any possible questions or doubts we have.
Okay, is available. Grazie.
Okay, so actually, I have one question that raised in my mind when we were speaking about possible configurations of the experiment, especially in that logo with the various characteristics and variables. And I don't know if this is a limitation or it's not. It's only my impression. But so in case you have not so many parameters to configure, then you can mix up the different values in a way that can be affordable for experimenting with different configurations. The point is that even with not so many parameters, but with an increasing number of parameters, that everything become much more complicated. So is there any way that you think to be doable for minimizing this kind of limitation? I see. Maybe it's not limitation, it's only and it can be also an added value. But is there any way for dealing with multiple parameters and a sort of automatic fine-tuning of the parameters that we have?
My answer would be if more parameters is something that confuses the actual mechanism we want to include, you are adding the complexity you don't need. So I would say it's fine if the model is very complex as far as it's a match with your research question and as long as you can deal with this complexity. So I would say if it's very reason to be many parameters, okay. But if it's parameter that adds to your core mechanism, I will just say avoid. I don't know, is this, and if Mario has another point of view or another answer?
Yeah, no, I agree with Rocco, and I wanted to add that there are automated methods, but the space of parameters explodes very, very fast. So what you're looking for in this case is gradient. If you don't have much gradient on one parameter, you try to explore this less. But then you never know, because a parameter that doesn't bring much change maybe, if you move it together with another parameter, will. So you have to calculate all joint parameters. And if you want to really to go in this direction, and you want to lose all hope, you also should consider that every algorithm that you have included in the agents, if you make complex agents, all those algorithms also should be explored in their variation. And then you have an algorithmic explosion of complexity, and really you could do anything. I mean, agent-based is very versatile, but this is sometimes a course. So it's good to have parameters that you can tune, because if you know the parameters from experiments, real life discussion with the stakeholders, then you can keep the parameter to some value and explore only the rest.
Which is an explanation, a justification you're giving outside of the explanatory mechanism, outside of the explanatory power. So, I mean, you always get an outcome. The point is that you have to understand where the outcomes come from. So, adding, there was, I think, Sobel method, there was kind of analysis of variance that it didn't really explain what actually the parameter was doing. So, that's what I think was not successful in the end. So I would say keep it short, simple is always the best solution, maybe. Or at least you very understand the mechanism, and then you are starting complexity. But also at some point you have to start to hand at some point. You cannot continually add. Andrea Di Renzoni.
Yeah, listen.
Yes. Just to understand if I grasp everything in the right way, I am an archaeologist, so I'm interested in the time dimension. So I cannot understand very well if it is possible, and if it is simple to model time comparing the time of the agent, that is the time of a normal life, in a very, very huge time scale. I try to explain in a better way. We are interested in the explanation of a phenomena that span over a huge quantity of time, let's say centuries or millennia, using the time life of the single agent. Is it possible to integrate this, because the interaction among agents is among people, or do we have to use another category of agent? And in that case, because I cannot figure very well how can we put the single agent into a big framework of an historical process. I don't know if you can understand my question, but maybe because I don't know very well the technical of the agent-based modeling. That's why I'm asking that. I don't know.
Maybe I can, Rocco, may I?
Yeah, okay.
Okay, I put, if you're interested in archaeology and agent-based, there's lots of studies there.
Yeah.
If you go to, I put a link on the website, on the chat, and that's something done inside the department. But also you can see the Ananazzi, which was
Yes.
experiment, which was one of the foundations of the also for agent-based modeling. And there, as far as I remember it, it's the pueblo itself is the house, which is the agent.
Yeah. Okay.
Yeah, you can, depending on your time scale, you can use the agent you need, which doesn't need to have the life of a person. Agents are not necessarily persons. They can be groups, they can be entire villages, and they can just take one or two decisions in their lifetime if you need time to run fast. So this is pretty easy to attempt. Of course, you're leaving much behind. There's a lot that you're not looking at if you run that fast, but you can run agent-based models that go the last centuries. But also in societies in which we described even some details of the life of agents, we were asked to run simulations for 30 or 100 years, and this was extremely challenging because then you only have the main events in the life of the agents. So they marry and they form a family, but then you start to feel all the demographic effects that you get in this kind of situations. Okay, I don't want to expand too much. Rocco, back to you.
Okay, I think Mario knows more about because archaeology I just know vaguely Nazi, but I think I mean the concept of time matter in terms of what's the effect of time because it's an evolution of the system. So I think I'm not into archaeology or ABM, and I don't know much to be honest, but I think if you try to replicate time as milliseconds, months, years, so on, you're really trying to fetch something that is an abstract measure. The time actually that you see in the computer is also true that is related to the thread, which is a very technical aspect of how the processing works. But I think from the understand the phenomenon, it matters if in 1 century nothing changes, imagine, and the agent just accumulates information. You don't need to model the time. The evolution of the system is when the characteristics of the system change. So that's maybe I don't understand the question, but if your question is how you can model thousands of years, something like that, I think it's really a dangerous question that doesn't look at the very point that you want to address the changes that occurred in the 1,000 years. If nothing changed, maybe the system actually didn't change. So you don't have actually evolution or transition of the system. Say you are in a stable equilibrium, eternal stable equilibrium. I don't know if it's possible, but maybe you have a cyclic equilibrium and your model can replicate. I think it's more important to you that you are managed to replicate these mechanisms of change. But this is the second, this is the month, this is 1 year. I think it matters as much as what you associate in changes in the system with this unit of time. So I think looking at the linear flowing of time, it's a dangerous exercise that will not bring you to your actual point. When your actual point should be how you can address the changes in the system, and this you can do. So I think it's time to be considered as the changes in the system rather than time as a linear variable independent by itself. I don't know. This is my understanding. What do you think, Mario?
No. Yes, it's more
Yeah, but
clear
Mario has
now.
no experience on it.
Thank you very much.
It depends. If you look at the link that I've posted, that was a long scale, if I remember correctly. It was made by Federico Cecconi. Wait. Oops. Sorry. A problem with the coffee. It was made by Federico Cecconi, and they were trying to match archaeological findings and their movement of goods across the Mediterranean. So it was very, very large scale, and I don't know if they went very far with that, but it was an attempt made.
Yes, I know something. I worked for a while with him, so it is not that simple, but yes, it's.
I think that what you should approach the agent-based with an open mind, and don't think that you can get precise answers to all your questions. It's a good instrument for formalizing what you know about the problem and trying to do some computation about it.
Yes.
The act itself of making everything formal and really putting into the machine everything that you know and you think it's relevant, it can cause it, but just this act can cause progress in what you know and understand about the phenomenon. Okay, I think that Andrea is looking at us. Back to Rocco. I'll be quiet from now on, and thank you everybody for being here.
Yeah.
Okay.
Thanks, Mario, for your answers. And also thanks, Rocco. So if I have still time, the only comments to close that also goes towards the future, I would say, in a sense that I would like to know if and how the work and research on agent-based modeling relates with the emerging topic on agentic AI that seems nowadays very, very popular. It's a sort of buzzword. But we have a lot. We have a lot of research and studies in agent, multi-agent systems, and now seems they are somehow reinventing the wheel, but with a different flavor. So I don't know if what's your point on that?
So far for me is I do a lot of discussions with Carmelo, Fabio, Longo, because they do multi-agent. I think my understanding so far, my opinion so far, is agent-based model remains on the aspect of the system to study the social phenomenon. Multi-agent follows the same processes of agent-based model, but it's more on coordinated systems. First, is not uncoordinated system, not, let's say, mutual adaptation. Even if you look at the mutual adaptation, this is within the scheme of planning through the machines, I would say. The agentic AI, I would say it doesn't address, for my understanding of agent AI, the actual interaction as foundation of the collective phenomenon and not from as a tool for research, which you do with agent-based modeling. And I know also some people use large language models or agent AI to say to study the questions you will use with the agent-based model. I think there you have the risk that you're cutting into the black box because you don't know what actually are the processes that describe the outcomes of the supposed system that the agent AI or the large language model has produced. And this is what you want instead to do with agent-based modeling. So I think here I'm a bit skeptical about this. I think you are missing the points using agent AI or large language models to replicate what you will do with an agent-based model because you want to put your hands on what are the parameters and what are the experiments you do with the agent-based model.
Well, I promise to be quiet, but there's much to do there. One of the things that the integration with agentic AI could bring over is the solution of one very old problem, which is if you want to have intelligent agents, something that agents really were bad at doing was planning. And current large language models are good at planning. So that's really an interesting point of overlap. Could solve one of the main issues we had with intelligence agents. And there's some work on that, but we probably need the conference of agent-based people to answer this. The answer is still much uncertain.
Okay, thanks. I know that Salvatore had to go a couple of, 10 minutes ago, more or less. So he cannot be longer with us, but he was very happy about the course and how you handled it. So many thanks also from Salvatore, and thanks to all the participants that spent these 2 hours more or less with us, and of course thanks to Rocco and Mario, who, in my opinion, set up a very interesting and well done course for our purposes.
Sorry, Andrea, Rocco did everything.
Okay.
But I mean, you know, you hired Rocco somehow, so it's also
Yeah, I mean, we're back to basic ethics of research. The people that have written the article, the people that got the money, not necessarily sign the paper. I mean, the people that do the work need to get the recognition.
Okay, thanks. So the last administrative communication I give you is that in case, so I know that many of you will ask for the certification, for the certificate of participation, so the attestato in Italian. I will deliver in the next days all these certificates. I will send you an email that points to a folder in which you can find a file with your name, so then you can download the certificate. I will send the certificate, so I will generate certificates for all the people that have registered to this call with an email address, I guess all of you, in a way that I can contact you via email. And that was the very last, communication. So many thanks again.
The slides, Andrea.
Yeah, send me the slides so I can send them to, I would say Stefano Carotenuto, who is taking care about the website, and we publish everything on the channels. So have a good lunch. It's now.
And applause to Andrea for the awesome organization.
Thank you for this.
Thank you for all
I'm shy.
very good organization. In so few times, so many information. Thank you so much.
Thanks.
Thank you.
Thank you.
Okay, see you for
course.
next course.
Who knows what the next method to be?
Yeah. Thank you.
So,
Bye bye.
Bye bye.
Bye.